Example 6. Find the critical numbers and intervals where the function is increasing and decreasing. For the function f of x equals 12x cubed minus 63x squared minus 540x plus 5. First, we'll note that the domain of our function is negative infinity to positive infinity because there are no square roots and no denominators. Our derivative, f prime of x, using the power rule, 36x squared minus 126x minus 540. I have to set this equal to 0, 36x squared minus 126x minus 540 equals 0. Now, whether you're attempting to factor this or use the quadratic formula, these numbers are all way too big, so let's see if we can find the greatest common factor. One way to do this is to make a little chart. We're going to put our GCF out here. We've got a 36, a 126, and a 540. And I don't worry about the signs until I do my division. I'm going to pick anything that I know will go into these three numbers. So they're all even. So I know that 2 will go into them. So I divide 36 by 2 to get 18, 126 by 2 to get 63, and 540 by 2 to get 270. Then I notice that 3 will go into all of these. 3 goes into 18, 6, into 63, 21, and into 270 it goes 90 times. I still see another common factor of 3. 3 goes into 6 twice, into 21, 7, and into 90, 30 times. Now, since 2, 7, and 30 have no common factors, my GCF is 2 times 3 times 3, which is 18. So I'm going to divide every term by 18, and these numbers will become smaller. And the good news is these numbers in here tell you how many times they'll go. So this is going to be a 2x squared, a minus 7x, and a minus 30 equal to 0. Now at this point, I could identify my A, B, and C, and I could use the quadratic formula. If you want to YouTube that to see how you would do it, that's fine. Or I would factor, and that's the method that I'm going to use. This is called the AC method. I multiply the A times the C to get negative 60. And my B is negative 7. So I need numbers that will multiply for negative 60 and add to negative 7. So I need one positive and one negative. So I'm going to just keep listing factors of negative 60. Negative 1 times 60, negative 2 times 30, negative 3 times 20, negative 4 times 15, negative 5 times 12, which I notice will add to a positive 7, and I need a negative 7, so I'm going to reverse the signs. So I'm going to take my 2x squared, and I'm going to write the middle term as negative 12x plus 5x. I'm going to factor out the greatest common factor from each pair. So that's a 2x and an x minus 6 for the first pair, and a 5 times x minus 6 for the second pair, which gives me factors of x minus 6 and 2x plus 5. Set equal to 0. The first one gives me a critical number of 6. The second one, 2x plus 5 equal to 0, gives me a critical number of negative 5 over 2. So now I'll take my critical numbers. The smallest one, negative 5 over 2, goes on the left. The larger one, 6, goes on the right. I will pick a test point. Now remember, negative 5½ is negative 2.5. I've got to pick something on the left of negative 2.5. I'll pick negative 5. In between is easy. I'll pick a 0 between a negative and a positive. And on the right-hand side here, I'll pick a test point of 10. So f prime of negative 5 would be 2 times negative 5 squared minus 7 times negative 5 minus 30. 2 times 25 plus 35, be careful there, minus 30 is 50 plus 35 minus 30. I now can tell that is positive. So the region to the left is positive. So that's all the numbers from negative infinity to negative 5 over 2. Next, I'll check 0. F prime is 0. 2 times 0 squared. 7 times 0 minus 30. 0 minus 0 minus 30 is going to be negative. So the region in between is a negative. And that is the interval from negative 5 over 2 to 6. And then checking on the right-hand side, f prime of 10 will be 2 times 10 squared minus 7 times 10 minus 30 is 200, because that's 2 times 100, minus 70 minus 30, and this is going to be a positive again. So the interval on the right is a positive, and that is from 6 to positive infinity. So in conclusion, our critical numbers were x equals negative 5 over 2 and x equals 6. The function increases in 2 intervals from negative infinity to negative 5 over 2, and again from 6 to infinity. And this function decreases in the middle interval there from negative 5 over 2 to 6. So these are our final answers for example number 6.